Hey, it's Michael from Arc Smarter. In this episode of How To Dynamo, I'm going to show you how to rotate family instances along an arc. Now, in a previous episode, I showed you how to place family instances on a sloped surface, and I used a theater as an example. We placed the theater seats in rows following the slope of the floor, and we used an arc to define each of the rows. Now, at the end of that tutorial, we rotated the theater seat instances so they were all facing forward. And that looked okay, but what we really want are the seats to rotate individually along the curve. So instead of using a single rotation value for all the seats, we want to determine the rotation of each seat about the arc center point. Now, to get this rotation value, we're going to construct some helper geometry in Dynamo. All right, let's switch over to Revit and get started. So I'm here in Revit and Dynamo. I have them open in a split screen, and I have my sample model here on the left-hand side in Revit. And you can see it's a very simple model. I have a sloped floor here, and then I have a series of arcs drawn to represent each row of my theater seating. Now, if I give this script a run, what you'll see is it's going to place a chair, an auditorium chair, a theater chair, along the arc, but it will be aligned to the surface of the floor. And you can see as well that it's rotating those, the seats, when they come in at the wrong angle, and it's rotating them all 270 degrees to face forward. And again, that's okay, but what we really want is we want to align each of these seats. If we were to go into a plan view, I really want to align each seat like this, so that if I were to kind of rotate it, I want it to kind of rotate so that it's perpendicular to the arc. And I obviously don't want to go through and do this manually. So what we're going to look at is a way that we can set that rotation using Dynamo. Let me just do one more to underscore how horrible it would be to do that for every single one. So let me go ahead and I'll just undo those. And if we look at our script, let me go full screen here. We're doing some rotation right at the very end. We're setting that rotation to a fixed value of 270. And again, the chairs, as they come in, they're not rotated. They're sort of rotated vertically. We want to rotate them 270 degrees, so at least they look better. Now, we're going to look at a method that we can use to rotate them, again, all about the center point of that arc. So each chair is facing sort of inward in a more typical theater setting. So within the existing script we have here, again, we're selecting our model lines, we're selecting our floor, we're using our curve project to project that curve from level 1, where the model lines reside, onto the floor surface. And then we're generating a series of points along that projected curve. Those points become our insertion point for our family instances. So I'm going to go ahead and I'm going to disconnect our degree value here in our family instance.set rotation, because we're going to construct a new series of values for that rotation. Now, the first thing we're going to do is we're going to get the center point for each of our arcs. Now, if we take a look at our curve project output, we can see that it's creating a series of ellipse arcs. And in fact, the project is projecting it on the sort of the top and bottom surface of the floor. So we're using a get item at index right here to make sure we only get the top projected curve. So I have an ellipse arc. I'm going to go into geometry, curves, and you can see that there is a subcategory here for ellipse arc. So I'm going to choose that, and I'm going to choose the center point node. So we want to get the center point for each of those arcs that are projected. I'm going to take the output from get item at index. I'm going to plug that into ellipse arc. And if I give that a run, in the background, I can see all the center points for all of my rows. So that's going to be kind of our starting point for determining the rotation value for each of the seats. Now, once we have that center point, we want to create a reference line that we're going to measure our angle from. So I'm going to do that by going to curves, line, and I'm going to create a line using by start point, direction, and length. So I know the start point is going to be my center point, so I can connect that. For direction, what I want is a vector in the y-axis. So if we're looking at our center points here for our arc, that's going to be the x-axis. We want to create a line in the y-axis. So I'm going to go to Geometry, Abstract, Vector, and I'm going to choose y-axis right there. So let's move that up. Let's give ourselves a little bit more space here. That's going to be our direction, and then our length, we're just going to use a hard-coded value of 20, and I can enter any value here. This will just make it a little more visible for me. So if I give that a run, I'm going to see a whole series of our kind of reference lines right there. So now that we have that reference line, what we can do is we're going to construct another kind of helper line. So we have our center point, and then down below we have all of our individual chair or our seat points. So we're going to create another line connecting the center point to each of those seating points. So we'll go back to our curves line, a subcategory here, and we're going to use by start point, end point. So at the end of this process, we're going to end up with two lines. One, our reference line in the y direction, and then two, we'll have all of our individual lines from the seat point to the center point. And we're going to then measure the angle between the two, and that's going to generate all of our angles that we can rotate the seats by. So back to our center point, seat point, we'll again use our center point node here. That'll be our start point. And our end point is going to be down below in our seat creation script. We'll use the curve points at equal segment length output. So if I go ahead and click run, I'm going to see all of a sudden I have a whole bunch of lines here. Again, we're connecting every single seat point to its center point. So we switch back into our node view. So this gives us with our two lines. Now to do our measurement, what we're going to do is we're going to use a node that's called vector angle with vector. So if I go into our, let's see, let me do a search for that. That one's a little bit tricky. Angle with vector, here it is. It is under the vector, well, let's pull that out so we can find that. Sorry, so it's under, abstract vector, and then within that, angle with vector. So this node takes two vectors, and with that, we can measure the angle between those vectors. So we're not measuring sort of the angle between the two lines. We're going to get the sort of the directional, the vector representation of that line, and then we can use that to measure. So we have our two lines here. We need to actually get their direction. So we can go back into our curves, curve, and we're going to look, actually we're going to go to curves line, and we're looking at the direction node here. So the direction node, we'll use two instances of that. That's going to return us a vector of the line. So what direction is that line heading? That's what line direction will tell us. And once we have that vector, we can plug it into our angle with vector. So I'm going to take our first line, which is our sort of baseline, and then I'll take our seat point to center point line. There's our two vectors, and then they plug into our angle with vector node. All right, so if I give this a run, I'm going to end up with a whole series of rotation points here. And you can see it's changing. So every single seat point is going to have a different rotation point. Now I can go ahead and I can plug that in directly into our node down here at the bottom. Let's pull that over. So if we take that angle, we can plug that straight into our family instance set rotation node. So I'm going to do a split screen. And if we give this a run, we'll see how good that is. And we can see that actually the rotation is great. It's rotating the seats. The problem is they're actually all backwards. So we're going to have to do a little bit of manipulation here. Everybody's facing not towards the stage, but towards the back. So to do that, we're just going to kind of swap our number around here. So these angle that we're getting out of our angle by vector node, I'm going to take that number into a code block. I'm just going to type angle. Oops, let's try that again. Angle, and I'm going to subtract that angle value from 180. And that's basically just going to rotate our angle. So I can take the output here from vector with angle, plug that in, and then that's going to plug into our code block, and then that's ultimately going to go into our family instance set rotation. So now if I give this a run, it's basically going to flip all of those seats. So when I look at this in plan now, I can see that my seats are now arranged so that they're perpendicular to the curve as that arc sort of curves along. So this is much more what we would look for in theater seating. We want those all to face towards the center point of the arc. And we do that by just doing a little bit of, creating some geometry. And we use that kind of helper geometry in order to get the rotation value. All right, so hopefully you found this useful. Leave a comment if you have any questions in the comments below, and don't forget to subscribe. Thanks, everyone. Bye. Thanks for watching. I hope you enjoyed this episode of How To Dynamo. If you did, go ahead and click the subscribe button to get more Revit automation tutorials. Also, check out my free Dynamo template using the link over there. This template contains 20 node groups for common Dynamo actions, and it'll save you a ton of time when you're creating your scripts. Just copy and paste the groups you want, and you're on your way. All right, that's all from me. I hope to see you soon. Bye.